special angles. Now we will deal with the topic called special angles, and the reason these angles are special to us is because they are used frequently in maths and science, and they output numerical values that can easily be remembered. Right, so therefore it is useful that we commit these values to memory as they simplify and expedite the calculation process. There's another reason these angles are important, because when we start dealing with a topic called radians, they become significant to us. And as I said, that in your first year of engineering or certain science degrees, you're not allowed to use a calculator. So understanding these values and what they output will become very important. Right, so we can prove these values mathematically, but it's not necessary, hence I will state them as a fact. But for the sake of curiosity, these sites can be found using proportionality. That's the topic discussed at grade 12. If you look at the 45, 90, 45 triangle, the two sides of the triangle are equivalent to 1, and the hypotenuse is equivalent to the square root of 2. If you look at the 60, 30, 90 triangle, then one side is equal to 1, the hypotenuse is equal to 2, and the other side is equal to root 3. Now the way I remember this is, I only remember the sign of 30. The sign of 30 is half. So what is sine? Sine is opposite of hypotenuse. So therefore I know the side opposite the 30 has to be 1. And the hypotenuse will obviously always be 2. And then automatically the adjacent side becomes root 3. With this triangle here, just remember 45, 45, it's an isosceles triangle. And these two sides are 1. And automatically using theorem of Pythagoras, I can find the root 2. Now it's very important that if you remember all of our trigonometric ratios like SOHCAHTOA rule, when you're finding certain values, like let's say we look at tan of 30. If I put tan of 30 into the calculator, you'll get root 3 over 3. And that's actually incorrect. Because if in the paper it explicitly states that you're not allowed to use a calculator, and you somehow get to this root 3 over 3, they're going to know that you use a calculator. That's the reason why memorizing these diagrams will become very important. So if you look at this diagram, sine of 30 is what? Opposite over hypotenuse, 1 over 2. If you look at the cos of 30, it's adjacent over hypotenuse, which is root 3 over 2. Exactly what we have here. You look at the tan of 30, it's 1 over root 3. Exactly what we have. Then look at this angle. In the eyes of this angle, what's the opposite side? The root 3 and the hypotenuse is 2. So therefore we'll have root 3 over 2. If you look at cos of 60 is adjacent over hypotenuse, which is half. If we look at tan of 60 is opposite over adjacent, which is root 3 over 1. If you look at 45, sin of 45 is opposite over hypotenuse, which is 1 over root 2. Cos of 45 is adjacent over hypotenuse, and tan of 45 is 1. Right? So if I gave you an example like tan of 30 plus sine of 45, right? And I told you to solve for this, then you look at your diagram, you'll draw you two triangles. Tan of 30 is what? Opposite over adjacent, which is 1 over root 3. 1 over root 3 plus sine of 45 is what? 1 over root 2. 1 over root 2. And then you'll have root 2 plus root 3 over root 6. Right? And that's how you solve this question. Alright, I just want to prove something to you. See if you use the calculator. If I put in here tan of 30. Tan of 30 is what? Root 3 over 3. So that's immediately where you'll get the answer wrong, because they start to rationalize the denominator is what they say. So that's the reason why you're going to be very careful when you're working with this. Work strictly with the diagrams. Take the answers from the diagrams, because for this value here, like tan of 30 and cos and sine of 45, these are the values that you cannot put directly into the calculator, because the teachers will know that you use a calculator. Right? So start training your mind to not use a calculator and remember these values, or even draw the diagrams in your page. But remember, like I said again, for the 60, 30, 90 triangle, just remember the sine of 30 is 1 over 2. This side becomes root 3. You can use theorem of Pythagoras and find that. And for the 45, 45, 90 triangle, you can get these sides here by saying 1, 1, and this side here can be found using the theorem of Pythagoras. Now, what's interesting about triangles is the whole idea of proportionality. Let me give you a brief idea into this. Let's say that you took two set squares. It's a 45-degree set square. And you measured this side here. And this side measured to be 30 centimeters. Then I can assure you that this side here will also be 30 centimeters. Right? And then this side here, what did we do to 1 to get to 30? We multiplied by 30. You do that to every side and you'll get the measurement of this side. So I guarantee if you put 30 times root 2 in your calculator, whatever numerical value this output, that will be the length of the side here. Right, so that's the whole idea of proportionality. Now, when we get to solving the questions using these ideas, you'd see exactly what I mean about proportionality, where I actually put this to the test. So what I'm saying is that this is the primary triangle. This is the 45, 45, 90 triangle. This is the primary triangle. And every other triangle will either be scaled up, so you multiply by some constant, right? Either scaled up or scaled down. So it could be a half of every side of this triangle. It could be a quarter of every side of this triangle. Or it could be 30 times every side of this triangle. But every other triangle will be a re-representation, either scaled up or scaled down version of this triangle. It's like the primary triangle. And this idea applies for any triangle. Like here, I can assure you, if you get a 30-degree set square and you measure this side. So listen to me. You measure the opposite side and you measure the hypotenuse. I can assure you that the opposite side will be a half the hypotenuse. Because if I divide by 2 here, I'll get 1. So if I divide by 2, I'll get the side here. I do that as an experiment so that you'll see exactly what we mean by this whole proportionality idea. Right, and let's say if this side here measured on your set square measured 30 centimeters, right? Then I guarantee that this side here will measure 60 centimeters. How? Because I know 30, if you multiply every side by 30, right, whatever numerical value you output here should be equivalent to 30 times the side, the basic triangle, the side of the basic triangle. So 30 times 2, this will be 60 centimeters. I'd put all of this to the test, and whatever numerical value this outputs, so this outputs 51. So you put this into the calculator, you should get approximately 52 centimeters. Right, so these are the things that you need to remember when working with these sections. With any triangle, you can literally use proportionality because the sides will be in proportion. Right, so just keep these ideas at the back of your mind. I will put it to practice and to test when we get to the questions.